Hello. So here we are in Nuke. As you see in this image, I've started working with Nuke 11.0 v2. It's relatively important for us today because I'm gonna set up the scene with a color pipeline based around ACES, which has been recently updated. And I believe that to avoid any confusion, using the same version as I do, or at least one which is as recent as mine, would probably help you because you would have the proper color spaces available to you. So here we are in Nuke. The first thing I'm going to do today is quite simply set up the scene, start by importing the elements. So in my case, the element will be in VFX 307 elements, and this is the name of our file, the RE2 ACD 0000 18mm 001. So let's bring this guy in. And here we have the plate. So let's straight away set up the in and output range of our Nuke script. So our plate runs from 1001 to 1066. So let's press S and let's make sure that these are the frame ranges we are using. That's correct. You can lock it if you are more comfortable with this. And let's have a quick look at our image. So as you see, we have a quite simple backward traveling. It goes quite fast. And as you may see, the colors are not that great for now. And the reason for that is Nuke by default is working in linear, but the files we are importing are in a specific type of linear, which is AP0. Let me try to show you this. So one of the cool things about the XR is that it's a very versatile format. It takes plenty of type of data inside. And of course you have access to RGBA, you have access to different channels, but one of the coolest aspects of EXR is that you have a lot of metadata written in it. So if I go to create a view metadata node, and I can now access all this data which is embedded in the XRs, we have access to a lot of information which was recorded at the time of the shoot, which for us can be extremely precious. You have information in there which can inform your composite. For example, the color temperature, the focal length of the shot, the length being used, which can be useful, for example, if you work on a show where someone shot camera grids, distortion grids, I mean. You also have important information regarding the color space. In our case, what interests us today is that it is encoded in ACES linear AP0. So ACES, if you don't know it, is a relatively modern color encoding system which was prepared by the Academy, which is supposed to help modern digital productions. It helps them to work in the same shows. Modern films, for example, can be shot in a variety of cameras, some very little, some very big, some professional, some not professional. And the ACES is kind of a common language for all those cameras. So all those cameras have color systems which allows them to be converted to a common linear encoding system, which is the AP0. So when you import an element like this one, which was shot straight from the camera, most likely it will be encoded in AP0 when you receive it, so that you are sure that whichever camera shot it, the colors will be relative to each other, will be coherent. Now, how to set this up? Well, we're going to start by going to the scene settings again, the project settings. And as you see, we have the color tab. So let's click on it. And by default in Nuke, your color management is set up to Nuke, which in our case is not gonna fly. So what we want to do is tell Nuke to not manage the colors at all, but instead we're gonna use OCIO. And in the OCIO config, we're gonna ask him to use ACES underscore 1.0.3. So that's the latest that was released, as far as I can tell. And here we're gonna end setting up a few more things. So now all the colors you are seeing in the viewer are starting to be managed from ingestion to viewing in the screen. They are managed by the ACES encoding system. So now we want the working space to be ACES CG, and that's what it is right now. ACES CG is a linear format which was specifically designed for us VFX artists, as CG implies. It is a linear format which is slightly, the primaries are slightly smaller than the ones which come from AP0, but they are very convenient for us to work with. So that's going to be our working format. That's what Nuke is going to do in its node, in color corrects, in any operations you do. It's going to show the ACES CG linear format. Now, for the float files, which are the ones which we bring around, the float files from CG, we're going to bring just simply ACES CG also. We're going to be working with CG files most of the time, the ones from Charles, and we should be good with that. Now, for the monitor, that's a bit different. It is very possible that you at home will get the best results using sRGB. However, in my case at home, I'm using a TV monitor as my screen, as my computer screen, and I found that I actually get more pleasant results, more natural results using Rec 709. Now, the results themselves of the image will not be that big, and again, the viewing LUT is just a viewing space, which is not baked into your output. So in a normal color pipeline, you would want to, of course, respect the color pipeline which is appropriate for your screen and which is probably given by your supervisors or just what you have set up formally in your company. But in my case today, well, in our case today, because we are working kind of outside of the pipeline, it would be good to just work with what looks good. So in my case, I set up these default preferences. Let me also switch to Rec 709 in my screen. There we go. And here I have my base plate, which is now slightly more pleasant. I have more range in the sky. I know that the values are there for me to work with. And you'll see later that one of the first things I will do is try to neutralize a bit the plate, make it slightly less overexposed, and make it a bit more compliant to what Charles was seeing on his side. Now, as you may have seen, I already made a small mistake. By default, I set up the import as ACES CG, which is good for CG files, like the renders for Charles. But actually, what we want for this file is to be imported and interpreted as ACES AP0. Now, ACES AP0 actually has another name, which is the one which we will refer to here, which is the ACES 2065-1. It's a bit confusing, but that's the official name of AP0. Now, this file now is imported. It has the appropriate color space, and of course it doesn't look exactly like what we want. It might be due to plenty of different reasons. In my case, I suspect that my color pipeline is not entirely accurate, but for theoretical purposes, that's what we should have. Now, what I'm going to do is first neutralize the plate, like I said, and for that I'm going to use an OCIO CDL transform. So the CDL is, again, it's a color decision list. It's a node or a function which is common to many color grading applications, and Nuke, amongst other things, can color grade. It is made so that people in color pipeline, color graders, compositors can share and exchange data about how they grade their elements. So in my case, what I want for this image is to lower the exposure a bit and also to lower the saturation. So one of the first things we want to do is make sure that the color transform happens in log. which is usually what companies or color graders prefers. So I'm going to go to ASUS-CC, which is color grading space, because it allows us to grade in log or emulate the log look. And now I'm going to enter some data. Now again, the reason why I'm entering data directly instead of testing by values is because most of the time these informations will be fed to you by someone, which is either the color grader of the film or maybe a supervisor, and these values are quite easily emailed, for example, which is very convenient for us. So in my case, I'm going to use the values I've set up formally. So, 509, and as you see, it's starting to look very weird. Yep. And to the blue channel, we have minus 0.0374. There you go. So these are the values I chose for the exposure, an offset of your grade in, let me pause the frame for a minute. An offset in log space basically is an exposure down or exposure up. And I'm also going to lower the saturation, which is a bit too strong in my case, and I'm going to put it to 0.73. Now, this is the kind of image I prepared in the past. That's roughly where I left Charles, and we should be good with this kind of look. Now, the next important thing is we would like to import every bit of data which we will need to composite this frame. So that includes CG renders and also our CG elements like geometries and 3D camera. So let's do exactly that. I'm going to read nodes, and here's my main directory. We're going to go to renders, book, and I'm going to load the beauty. So I can load the version 3 of the beauty. I'm guessing we will not have fed you the others. And I'm going to click next, and I'm going to load the occlusion. Same thing, next, book, and I'm going to load the shadow. There we go. So if now we open, we have those 3 files. And as you may see, they are loaded by default in ASUS-CG, which is what we want. We have the beauty of the car, which we can see here, and we have the occlusion. All right, so all of these 3 are great. We know that we have all the frames on each of them. And we know that we're going to need to combine them with our plate. Now, of course, we also want to have a few 3D nodes. So for that, I'm going to start with the camera, which I know exists because Charles tracked the shot and made sure that we were rendered in 3D. So I'm going to go to the camera, read from file, and I'm going to go to file, and I'm going to load camera version 1, V1, this one. There we go. Yes. Up. And if we go to the 3D space, we should have a nice camera, and we can double check that the camera is moving. Yep, that's correct. And now similarly, I'm going to import the car itself. So read geo, file, and let's have the car animation open. And we have now a bunch of geometries which are suggested for us to load. Let's have them all for now. Create all in one node. And give it a bit of time. And after a bit of loading time, my car is loaded in the scene. So I can go see it. As you can see, it's not super fast. There we go. But yeah, we have a nice car, and it is hopefully moving with the camera. So we know that everything is fine. The animations have been imported, and that will be used as a great reference. Now we also need one last tiny bit of geometry. So read geo, and read, and we're going to read the ground, which is the geometry that Charles solved and exported for us to use. It's a geometry he used to cast the shadows of the car and render it. And we're going to use the ground as a reference for some work on the shadows later. Now, as you can see, I have all these nice 3D elements. You might also notice that my computer is a bit unresponsive because this is a very high resolution mesh. So I'm gonna look at my 2D image instead, and this should allow me to be a bit more quick in the DAG, which is awesome. All right, so one of the things I like the most when I start setting up my script is make sure that every bit of information is laid out properly and in a way which is readable, including from a distance. The more you work professionally, the more you will see that, well, comps never happen exactly the way we want. The client might have very odd requests, or sometimes you might find a lot of issues that you did not anticipate. And the result is that the scripts tend to become larger and larger as time goes by. So it's always good to have kind of a code. It can be unique to yourself, but ideally you would want to have something clear, kind of a color chart or organizational methods which will allow you to always be able to read your script. Ideally, you want these methods to be readable by anyone. So one of the first things I usually do is that I put backdrops everywhere. So I will try to start with the camera. I will add a backdrop around the camera, which I will rescale a bit, and I will, and I will name it camera because we want to be clear. And I will rescale it so that the text doesn't go across. There we go. I will create another backdrop for these little guys. And this one I will name, I think I will name it data. There we go. And I can probably put it around my plate. There you go. Another one. I make it very readable. There we go. So even from a distance, as you see, the camera is very readable. It's different colors, color data. Same, I'm gonna put another slightly different color. There we go. Plate, whichever colors. Usually it can be gray, it can be green. Again, it's a matter of preferences, but the idea is that you try to stay consistent so that the plate will always keep the same colors, that the camera will always be the same colors, and so on. Now the last one we really want to make sure to have is the right node for the output. It's going to be a right. We're going to connect it to our plate directly for now. And this one, of course, also needs a backdrop. And for the backdrop of the output, I really like to make it very clear that this one is extremely important and extremely visible. So make it big. Yep. And I usually give it a color which is almost pure red, but a bit darker. So let's go to red, a bit darker. There we go. I'm going to call that output. Again, the reason why I do that is because it allows me to, well, first of all, visually know where my input is, where my output is, and if any compositor were to take my scene, he would know straight away where to look to find every important bits and pieces. So this one is, I think, very important. Of course, you might have different preferences, but stick to that, and you'll be grateful to yourself once you do. Now, the other thing I want to point out, and it's extremely important, is at this setup stage, you are already preparing what we call usually the main spline of the main branch of your script. It's a backbone of your script. This vertical line, which goes from top to bottom, you want to respect it as much as you can, because it's a small sacrifice to respect that, but in the end, it's a huge benefit to just be able to read that line from anywhere in the script. Know that your data goes from the top to bottom. You're not going back up. You're not going to the left or right. So it's extremely useful to respect that. Now, I'm gonna just, out of curiosity, I'm gonna merge my beauty on top of my main image to start looking. All right, so we have the car here, and straight away we know that some things are not quite right because the resolution is not right. The resolution of my images from Charles are 1080, while the resolution from the plate is 2K. So we want to edit that properly. So today I'm not going to be too concerned about how we reformat. It's been set up by Charles originally, so let's do the same. We have a reformat, and our format, our scene format should be 1080, AG 1080. There we go. So this way, yep, we are rescaling, and yes, we are resampling the plate, which is not great, but well, for today, that will be okay. I will change the size of my arrows because my graphic card driver doesn't support really well the subsampling. So let me go to Edit, Preferences, up, and not graph, and let's put a bit more width. Hopefully it will help us see the arrows. All right. Oh, and there we go. We have a script with slightly more visible lines. They will still tend to disappear. I think it's a driver issue, but I will try to make it easier for you to read as much as possible. We have set up, imported the main elements. We have set up the main, the backbone of our script, let's say. And I'm just gonna save it so that we can carry on. So saving, again, it's can be an important process. Ideally, you always want to respect a certain convention. It makes sorting files a bit easier, and overall, it's just good practice. It allows people to track what you have done on a specific shot much faster. So in my case, it's going to be Simon, and compositing, and let's put a version number, version 1.nk. And with that, whichever user grabs my scene knows that this is the shot for VFX 307. I'm the artist, and the department is compositing, and it's the first take. So that's quite useful for tracking purposes, and it's always a good practice to make sure you have this kind of information in your scene file. And save. Back. And there we go. So this concludes the first part of setting up the scene. And I will now see you for the next part of the lesson.